Hi, this is Ghubaida, and today we are going to simulate our fourth project. And today's project is an automatic irrigation system with a notification to the user. It's a nice project. In this project, I've used a couple of devices like Arduino Uno. I had a soil moisture sensor, ultrasonic sensor, a liquid crystal display, GSM module. In this simulation, I've used a visual terminal device and the two pumps, a watering pump and tank pump. In this project, the moisture sensor was used to measure the soil moisture content, and also the ultrasonic sensor here was used to measure the level of water inside the tank, right? For the liquid crystal display, I've used this to display the values of moisture content and also the level of water inside the tank in percentage form, but also the status of two pumps, or whether on or off for the tank pump and also for the watering pump, right? Okay, so let me give you a brief description on how the project works. Let me run it a little bit, but let me stop it. Here we go. So as you see here, as I said, the liquid crystal display is just used to display the tank level, the moisture content, and the water pump status, also the tank pump status. So we have two pumps over here. The tank pump, this pump was used to supply water from the well to the tank, and the label of the tank will be displayed on the liquid crystal display. And also the watering pump is the pump that is used to supply water from the tank to the farm, right? So it will be used to water the plants, and the status for that pump is also indicated on the LCD. As I said, the soil moisture content will be used to measure the moisture content in the soil, and that content will be also displayed on the liquid crystal in a percentage form. And also I've used a GSM module. The GSM module in this project was used to send the text messages to the farmer on the status of the pumps. When the tank pump is on or the watering pump is on, so there will be two messages that will be sent to the farmer. When the pump is on, the text message to the farmer will be sent that will say tank pump is on. So using those messages, the farmer will know how the system is going. Like, okay, now the tank level is below the tank pump, now is taking water from the well to the tank. Okay, now the watering is going on, like that. So it will enable him to know exactly what is happening on the farm. So this was my project. Now I've written a code here. Let us take a look on the code, and then I'll be back to run the simulation. Better let me add some. Sorry, I don't see. So the editor configuration, I want to increase the font to 12. I think it'll be enough. Okay. This is the code. The first two lines I've just included the library files for a liquid crystal display, but also I've used a software serial library file. This software serial library allows me to create different TX and RX pins for the GSM module that I've used. So instead of using pin number 0 and 1, as my transmitter and receiver pin, I've just created another pins, which is pin number 2 and pin number 3 as receiver pin and also transmitter pin. I always prefer this way of connecting my devices, so I don't always use the pin number 0 and pin number 1. So I'm always using this software serial to create another TX and RX pin. Okay. Pin number line number 4 to number 8 is just the definitions. For echo pin is connected to pin number 9, trigger pin number 10. These are the pins for the ultrasonic sensor. Our tank pump is connected to pin number 4, watering pump to pin number 13, and the moisture sensor to pin number A0, right? So I have also the variables, long duration to get the duration of the ultrasonic sensor once I turn on the trigger pin, right? And also the distance to store the readings from the ultrasonic sensor. I have a variable moisture value that will be used to store the moisture readings, and also I have a distance percent and a moisture percent. These are the variables that will store the percentage value of the distance reading, and also the percentage value for a moisture content reading, right? As you see, I've created an object SIM900. This is my object that will allow me to send the text messages to the GSM, right? And also another object LCD. In the setup function, I've just initialized the two objects LCD and also the SIM900, right? Okay. And I've just configured the other pins of the input and the output, as you see here. You can just download the project simulation file and take a look on the code by yourself. If you find any problem inside the code, you can just ask me and I'll be there to help you. In the loop function, I started by getting the distance, measuring the distance of the water level inside the tank. So if as we know, to get the readings, to get the distance using ultrasonic sensor, we only need to turn high the trigger pin for some microseconds, and then just turn it off, and then use the pausing function while echo pin is high to get the distance, to get the duration, sorry, and then just multiply the duration with this constant. If we are normally using it as a word from the word formula to get this constant. So duration times 0.017 will be getting the distance, the actual distance or level of the water inside the tank. So I've used map function to convert the readings to percentage form, right? Okay. And then at the end of the loop, I've just called this function here, condition function. I've created several functions, different messages for different messages to be sent. I have this void SMS that's will be that has a watering pump is off message, and also I have a SMS1, another message, SMS2, another message, and SMS3, another message, right? And the condition function, I've just created a condition using if statement. So if the distance percent, if the percentage of water inside the tank is above 65, I'll be turning off the tank pump. And also if the moisture percentage value is less than 85, I'll be turning on the watering pump. This is the main condition. If the tank level is above 65, I can say there is enough amount of water inside the tank, so we need to turn off the tank pump so that to stop supplying the water from the well to the tank. And if the moisture content is below 85, automatically we are going to water the plants. So if it's above 85%, we are going to to turn the watering pump off, and if the tank level is below 65%, I'll be turning high the tank pump, so that's to supply the water to the tank. Those are the two main conditions that I've used, and also I have another functions for the LCD to change those status. When the tank pump is on, I would like to see on status on either pump, if it's a watering pump or a tank pump. Right, now let's see how it works. To simulate the ultrasonic sensor, I'm just using this potentiometer to change the values of the readings of the ultrasonic sensor, and also to change the readings of this soil moisture sensor. I'm also using this potentiometer over here. Right, now as we see here in the LCD, the tank level is 86%, which is more than 65%, so the tank pump will be off. Now, so as you see here, the tank pump is off because the tank level is 86%, but the moisture content is 63%, and inside the condition we say that if the moisture content is below 85%, the watering pump has to be on. So now you see here the watering pump is on, right? And the text messages that are sent to the farmer that the tank pump is off, and that's true, the tank pump is off and the watering pump is on, and that is true, the watering pump is now on. Now let's add some contents of moisture in the soil. So if we add to that point, I would like to see here the moisture content. Okay, now the moisture content is 99%, which is above 85%, right? So the watering pump has to go off. As you see here, the relay has opened, and the message that is sent to the farmer is that the watering pump now is off. So let's reduce the amount of water inside the tank. So use this one minus sign below there. Okay, now the tank level is 43%, right? And our condition is if the water level is below 65%, then the tank pump has to go on. Now the tank pump is on. Now the water is supplied from the well to the tank, and the message that is sent that the tank pump is on, that is true, and that also the watering pump is off, obviously that is true. So that's how I simulated this project. So you can just download the project simulation file, copy the code, and gather the materials, the components, and build it. You can build one of your own and implement it if you liked it. In the next video, I will add another important feature. I'll try to add an RTC module, a real-time clock, so that we can choose the working hours of our system. Maybe we can start watering the plants at 8 a.m. and then again we're going to water the plant at maybe 17 p.m. right? So at those hours we are going to measure the content of the soil, because the reality is, if the soil moisture maybe at 14 p.m., of course the soil may be dry, right? And the soil moisture will detect that, and we are going to water the plants. So it will be unlogical, because we are going to kill those plants if we water them at right at noon, right? So we are going to use RTC module to operate our system, maybe from 8 a.m. to 9 a.m. and then choose another working hours, maybe from 17 p.m. to 18 p.m. right? So thank you for watching this video. Just subscribe to my channel for more project simulations. So in the next project simulation, I will add that feature to this project, and also I'll give you another video on a home security system. It's a very nice system. I'm sure that you are going to like it. It's a little bit different from other systems. It has some more features added to it. Thank you guys. Just like the video, just keep subscribing to my channel for more project simulations. Thank you.